Okay, the next problem is very similar to the equipment rental problem that we saw previously. This one is a car manufacturing company, and they have 5 different models that they would like to make, and there is steel resource required and steel available is 6,500 tons. The labor, how much is needed and how much is available or given. And if you select a particular model to build, then you have to build at least a certain number. Okay, so this way, if a model is selected, then that model not being manufactured at all, that kind of strange situation that we saw in the previous problem will be avoided. So there is a minimum production level, and then profit contribution per unit is given, and we want to set up a model that would do 2 things. One is select which models to make, and for the selected models, how much to make. So it's very similar to the previous problem. Let's look at the Excel file. Okay, so here we have the inputs. Okay, so these are the steel needed, labor needed, and minimum production if a product is produced. And we have the profit contribution. So let's make that into a currency format, no decimal places. Okay, now production. Okay, produce at least minimum. Okay, so that's your 0, 1. If it is 0, then you produce none. If it is 1, you produce at least the minimum. Okay, and then units produced. So that's your production quantity. So the minimum production is you take the minimum quantity and you multiply by the 0, 1 variable. Units produced must be greater than or equal to minimum production, or minimum production must be less than or equal to the units produced. So that makes sure that the floor is met. For logical higher level capacity, then remember what we did in the previous problem. So let's add 4 more rows. And we'll set up the maximum limit with steel, maximum limit labor, and then maximum limit, and this is steel available. Let's give a name. Steel available, and this is labor available. So we take steel available, and if we use that steel, the entirety of it in compact car alone, then the maximum that you can produce is that. Now if you take the labor and apply that labor entirely to compact cars, then that's what you can make. So the minimum between the two is the maximum possible value for compact car manufacturing. We copy that. So you get the maximum limit. So that's our logical capacity. You take the maximum limit and you multiply by the 0, 1 variable. Yeah. And that should be what we produce must be less than or equal to that upper limit. So we have a lower limit and then an upper limit. Okay, let's give some names now. That, that and that. Okay, and we'll give names to these two. So you get some product of units produced with tons needed. That will give you the steel used. Some product, units produced, and labor will give you labor hours used, and that should be less than or equal to what is available. So those are two constraints. And the profit then is some product of units produced with profit contribution. So that's our objective function. So let's give names here. Resource used, resource available. Solver, we want profit to be maximized. Changing cells is that and this. Okay, constraints are resource used less than or equal to resource available, and then here minimum production should be less than or equal to units produced, and units produced must be less than or equal to capacity, logical capacity. Okay. And then we have that should be binary. Okay, so that's non-negative, simplex LP, and solve. And then see whether these are units produced or whole numbers. Okay, now this one is not whole number. So let's go back in and add that production quantity must be integer. And we need to make sure that the options are set properly. Okay, so let's ignore constraints and let's make that into 0. Whether that makes a difference or not, no. Alright, so that's our solution.